Hello again, everybody. Welcome to a new screencast lecture. Tonight, topic is how do you calculate acceleration? And tonight, our broadcast is brought to you by tap water. It doesn't taste real good, but it's really, really cheap. Basically, it's free, and free is good enough for me. The first thing we want to take a look at is think about this. Acceleration is calculated, it is not directly measured. This is similar to what other measurement that we just recently learned? Well, of course, you should have answered speed. Speed is calculated, is not directly measured. Acceleration is calculated, not directly measured. So you won't be able to automatically measure acceleration. You need some other variables to be able to calculate it. And let's talk about calculating acceleration. Here's a formula that I would like you to know. Acceleration is equal to the final speed minus the initial speed divided by time. So in other words, it's the change in speed. And sometimes that's written as delta speed. Boy, I have a new program, and I'm just trying it out tonight for the first time to help me write on the screen. And right now, I'm not doing real well. So we have the delta speed, the change in speed, divided by change in time. A good way to abbreviate this would be A for acceleration is equal to S final, so speed final, minus speed initial, divided by time. And this looks kind of weird to you probably, but the way this is read, these are called subscripts, kind of like if you have 3 squared. This is called a superscript, this number up here. This is called a subscript. So S sub F minus S sub I divided by T. That's how you would read that. Let's take a look at this in an awesome animation picture form. If we have this car, she's waiting at the starting line. What is her initial speed? How fast is she going at the starting line? Well, of course, she's going 0 miles an hour. And then let's say she hits the gas. She starts moving forward. Her speed starts to increase. So after one period of time, she's at this line. After some more time, she's here. Some more time, she's here. And like I said, this is some amazing animation for you. And here we go. So at the end of the track, her speed is 30 miles an hour. So she started here at 0 miles an hour. Okay, I see what I don't like about this program. I can't see where the cursor is, where I'm drawing. So as soon as I press a button to actually start to draw, it vanishes. So 0 miles per hour here, and she ends the race at 30 miles an hour. So we need to figure out what is her acceleration. So to be able to figure out the acceleration, we need some information. We need to know the speed final. We need to know the speed initial, and we need to know the amount of time it took her to do that. So let's go ahead and plug in our numbers. And if you recall, when we did speed calculations to get able to get all 4 points, we first need to write the equation. So in this case, we're going to use A equals S sub F minus S sub I over T. And then we're going to plug and chug. We're going to plug in the numbers. Now, if you remember, she started at 0 miles an hour. That's her initial speed. So that goes here. She ended the race at 30 miles an hour. So that goes here. So it would be 30 minus 0. And then we divide that by the total amount of time that she took. And she took 5 seconds. So it would be 30 minus 0 divided by 5. You can go ahead and punch that in your calculator. And you get 6. Now, the unit can be a little bit tricky. This is what unit you're going to use. You're going to use miles per hour. And that's going to be per second. And the way you figure that out is that this is her speed. 30 miles per hour is her ending speed. Her initial speed was 0 miles per hour. So that's her unit of speed, is miles per hour. So 6 miles per hour. That's her average speed increase every second. On average, her speed increased by 6 miles per hour every second. You may use this acceleration formula 3 different ways. Here are 3 different ways that you can set up this formula. So if you want to find out acceleration, you do acceleration is equal to speed final minus speed initial divided by time. Let's say you have this information, the starting speed, you know the rate of acceleration, and you know how long the object or the car accelerated, you can figure out its final speed. Or if you want to know how long the car accelerated for, if you know the final speed minus the initial speed, you divide that by the acceleration. That will give you the amount of time that it actually took to do the acceleration. Here's a practice sheet that you can take a look at, and here they are on the screen. This is the first question. Reads, a roller coaster speed at the top of the hill is 10 meters per second. So if you can picture this, here's the roller coaster hill. The car is going like this up the hill, and then when it gets to the very, very top of the hill, its current speed is 10 meters per second. And then it's going to go down the hill, it gets down to the bottom hill. As it does that, its speed is going to increase. As it gets to the very bottom of the hill, its top speed is going to be 26 meters per second. So it increased in speed from 10 meters per second to 26 meters per second, and it took how long to do that? Well, it took 2 seconds to do that. So we do have all the information we need. We have the final speed, which is here. We have the initial speed, which is here. And we have the amount of time, which is here. And if you hear a bunch of screaming in the background, that's my boys. They're playing Madden, and they're getting a little carried away. Hold on a second. Now we have this information here, and now we need to actually do the calculations. Now let's see if I can figure out how to erase this. Clear page? That doesn't... Do I want to do that? Yeah, hey, it worked. Cool. All right, so I erased that information. So now let's go ahead and actually do the calculations. Now remember, the first thing I need to do is figure out what formula I want to use. And I need to find out the acceleration. So I'm going to use this formula right here. So I'm going to do acceleration is equal to S sub F minus, I'm getting a little better at this, but it's still hard to do, S sub I divided by T. And then I'm going to plug and chug. I'm going to plug in the numbers. So what is the final speed? Hopefully you know that is 26 meters per second. And then we are going to subtract the initial speed, which is 10 meters per second. And then we're going to divide that by the total time, which is 2 seconds. And we get 26 minus 10, which is 16, and we divide that by 2, and we know that that is 8. Hopefully we can figure that out. You can use a calculator if you have to. And then we need to figure out the units. And again, it could be a little bit tricky. It's going to be meters per second, which is the speed unit, meters per second, and it increases 8 meters per second every second. So the correct answer is 8 meters per second per second. That is the unit of acceleration. Sometimes that's going to be written, like you'll see in the textbook, it's going to be written as 8 meters per second squared. So try not to get confused by that. I know it looks really weird. It's 8 meters per second squared, and that's because, you know, if you're a math person, you might get this. If you're not really that into math, you might not get this. But what it is that seconds is really seconds divided by 1. So it's meters per second divided by seconds per 1. And if you remember how to divide fractions, what you do is you multiply by the reciprocal. So it's meters per second times the reciprocal of s over 1, which is 1 over s. And again, if you don't understand this, please don't panic. It's not really necessary for you to understand. This would be for a higher math level student. Meters per second squared. My handwriting is horrible with this program, but that's supposed to be m over s squared. All right, hopefully that makes some sense. And we're ready to move on to the next question. Now we have in this other question here, it says a go. Let's assume this is a car. A car goes from a stop to 50 miles per hour in 4 seconds. So let's picture this. You have a car, and boy, that's a great looking car. Here's a car, it's stopped, so it's going how fast? Well, 0 miles per hour. And then it's going to speed up. And if you remember, speeding up is called a what type of acceleration? Hopefully you remember. Let's see, so 0 miles per hour, and then it ends up going 50 miles an hour. Yikes. I need to get a different program. 50 miles. I mean, it's better than nothing, so I'm not going to complain. It was free, so I guess you would pay for 0 miles per hour, and it goes to 50 miles per hour. We need to figure out its rate of acceleration. So again, let's use this formula. Acceleration is equal to S sub F, the final speed, minus the initial speed. We're going to divide all that by the amount of time. So let's go ahead and plug and chug. I'm going to use a different color. And the final speed is 50. The initial speed, it was at a stop, so it's 0. And then its time is 4 seconds. So 50 divided by 4. And again, pull out your calculator.
So 50 divided by 4 is equal to 12.5. And then we need to figure out the units. Well, it's this unit of speed over the unit of time. So the unit of speed is miles per hour. Unit of speed over the unit of time. Now, some people can make it confused. You think the unit of time is hour, but it's not. Because remember, this is the unit of speed. It's kind of a package deal. So it's miles per hour every second. There's your final answer. So it's 12.5 miles per hour every second. Not bad. Hopefully you're able to do that. Okay, here's a couple more. So go ahead and try this one on your own. I'll get right back to you. What I recommend you doing is pausing the video here, and then when you restart it, I'll have the answer for you on the screen. Okay, hopefully you have something that looks a little bit like this. You have the formula, acceleration is the speed final minus the speed initial, and you divide that by the time. Then plug in your numbers. Your final speed is 0 because it goes from 65 miles an hour to a stop. So 0 miles an hour, its initial speed was 65 miles an hour. So 0 minus 65 divided by 5. And so you plug in your numbers, and you get 0 minus 65, and then hit equals. That's negative 65. Divided by 5 is equal to negative 13. And here's the tricky part again. Speed is miles per hour. And then the time is seconds. So it's 13 negative because it's a negative acceleration. Negative acceleration. What does negative acceleration mean? Negative acceleration, A-C-C-E-L, acceleration. I can't really read my own handwriting here. Negative acceleration means that the car is slowing down. So, you know the car is slowing down, so a good way to check yourself if you did this right is that you know it's slowing down, so you should end up with a negative acceleration, negative 13. So if you would have goofed up and put 65 here minus 0, you'd have gotten a positive number, and since it's slowing down, you know you did it wrong. So make sure that you know ahead of time that this is going to be a negative number. That's a real good tip for you that you can use to figure out if you are going to get the correct answer or not. All right, here's the next one. A man has acceleration. Oh, so now we know the acceleration. So this is going to be a little bit different. So it says we're looking for how much time will it take. So the amount of time, and if you recall, we're going to need to use this formula right here. Time is equal to n speed, the final speed minus initial speed divided by the acceleration. So the time is equal to the speed final, the s sub f minus s sub I divided by the rate of acceleration. So that's the formula we're going to use. I'm going to go ahead and pause this. You should pause it yourself, plug it in the numbers, and see if you can get the right calculation. Go for it. Okay, we're back with the next step. So we plugged in the numbers. The final speed is 15 miles per hour. The initial speed is 0 miles per hour. That goes here. The rate of acceleration is 2.5 miles per hour per second. Now, when we look at this number right here, the way we can interpret this is that for every second that goes by, the speed of the car will increase by 2.5 miles per hour. So let's say it was 0 miles an hour. After 1 second, how fast is the car going to be going? Well, it's going to be going 2.5 miles an hour. After the next second, it's going to increase another 2.5 miles an hour. So it's going to be going 5 miles an hour. After that, another second goes by. It's going to be going 7.5 miles an hour, etc., etc. So that's how this works. So we wanted to figure out how long is it going to take for that car to get up to 15 miles an hour. So we use our calculator, and we plug in the numbers, which you did here. Now we're going to chug 15 minus 0. You could probably skip that step if you wanted. 15 minus 0 divided by 2.5 is equal to, what? That does not make any sense. This is a good example to stop and say, well, my calculator says 0.6. That doesn't make any sense at all. That would mean that it would increase in speed to 0.6 seconds. That is not correct. So I must have typed in something weird. So let's try that again. 15 minus 0 is equal to, and then divided by 2.5. I'm kind of glad that happened. And we get the answer 6. Now that makes a lot more sense. So 6 seconds is how long it will take for that car to accelerate from 0 to 15 miles an hour at an average rate of 2.5 miles per hour per second. Not so bad. Okay, and then finally, we have this. A car has an acceleration rate of negative 25 miles per hour per second. How long will it take the car to stop if it is traveling 75 miles an hour? Okay, now we need to figure out time again, so we're going to use the same formula. It's going to be time is equal to speed final minus speed initial divided by the rate of acceleration. And the interesting thing about this is our rate of acceleration is negative. That means that the car is doing what? Hopefully you said slowing down. So let's plug in our numbers. The final speed is what? Well, it's going to a stop, so it's 0. And this is 0 miles per hour minus the initial speed is 75 miles an hour. Okay, hopefully you caught my error already. So this should be 75 miles per hour. And we need to divide that by the rate of acceleration, which is negative 25 miles per hour. That's a rate of speed. And that means that the speed of the car is going to decrease by 25 miles per hour every second. Now we've plugged. Now let's chug. Let's get our handy dandy calculator. And we do 0 minus 75 is equal to negative 75. We want to divide that by negative. How do you do a negative sign on this? Negative 25 negative equals 3. So that means it would take 3 seconds. Now, if you did the division wrong, like if you have this set up and you did 75 minus 0 divided by negative 25, what's going to happen is you're going to end up with a negative number for time. That doesn't make sense. So you'd end up with negative 3 seconds. Not sure what that would mean. So it would take negative 3 seconds to do something. Doesn't really work out. So if you get a negative number for time, you probably did something wrong. Go back and take a look at it. All right. So that's it for tonight. Not too bad, hopefully. And we'll get some work in the classroom, and hopefully we did okay. We'll check it out later. See ya.